Hey guys, welcome to Graphs Day 1. In this unit, we are going to be starting off by reviewing how to visualize data using pie charts. And so this portion of the unit is going to be a culmination of the skills that you've learned in fractions, percentages, and circles. Later in the unit, we're going to do some other really fun stuff. We get into negative numbers in this unit. We get into the coordinate plane and learning how to plot points and all sorts of good stuff. But first, let's do a little review with fractions. Okay, so we've got in front of you a table which shows the number of t-shirts of different sizes sold in a shop on a certain day. They sold some size smalls, mediums, larges, and extra larges. So we want to know, first of all, how many shirts were there all together. And if we add all these up, 9 plus 18 plus 6 plus 3, we're going to get 36. Now on your notes, the number 1 says, what fraction of the t-shirts are of size small? So we want to know size small, and you've already got it printed for you there. But size small had 9 t-shirts sold. And so if we want to know the fraction of the whole that they sold, it's going to be 9 out of 36. And then when we reduce that by dividing by 9 over 9, we get 1/4. So 1/4 of the t-shirts sold were small. The next question says, what fraction of the t-shirts are of size medium? And of course, 18 out of 36 are size medium. So 1/2 of the shirts sold were size medium. You get the idea. The next question asks, what fraction of the t-shirts are size large? 6 out of 36 are size large, which simplifies to 1/6. Now I just want to remind you guys, when we say 6 out of 36, remember that my fraction bar means out of. So when you see these words right now, it means a fraction, 6 out of 36, okay? And then finally, what fraction of the t-shirts are size extra large? And 3 out of 36 are size extra large. So we'll write that as a fraction, 3, and then out of my fraction bar, 36. And when we reduce that by dividing by 3 over 3, we get 1/12. Okay, so in this case, I have a bunch of t-shirts sold, and I expressed the kinds of t-shirts sold as fractions. Now, all of those fractions will add up to 1. So in this story, my whole was 1, which also equaled 36. Okay, now I know that's a little bit confusing, but this is the same concept that we learned in percentages. So if we were to look at a bar model here and label it like this, where the whole is 100%, you know that that 100% could stand for just about any number. So, you know, for example, 100% of the t-shirts sold that day would be 36 t-shirts. Well, when we're looking at circle graphs, we can use fractions or we can use percentages to express the whole. When we're making a fraction circle graph, those fractions are going to add up to 1. Okay, so, you know, we'll partition this in different ways, that maybe like this, and I'm going to have a nicer one for you here in a minute, but all of these portions of the circle are fractions of the circle, and they add up to 1. Okay, so what is the lowest common denominator with all of these fractions? Well, it's going to be 12, right? Because I can divide 12 by 4, 2, and 6. So let's go ahead and change all these fractions to 12ths. We'll multiply 1/4 by 3 over 3 to get 3/12. 1/2 by 6 over 6 to get 6/12. 1/6 by 2 over 2 to get 2/12. And of course, I don't have to multiply 1/12 at all. And then when I add all of those together, 3 plus 6 is 9, 9 plus 2 is 11, and 11 plus 1 is 12. And so it does add up to 1. So we can take those fractions and we can divide up a circle and make a graph from it and express data really quickly, which is really cool. So let's take a look over here. We've got all these fractions, and these fractions of the whole are also going to be the same fraction of the whole circle when we draw those on a pie chart. So let's just take a look at that 1/4 right there. Well, let me just remind you about what our fractions were in terms of 12. So this was 3/12, 6/12, 2/12. And if we go down here, and shade these, my circle down here is divided up into 12 sections. So let's go ahead and shade these fractions in as 12. So let's start with 6/12 right here. 1, 2, 3, 5, 6. All right, so this fraction up here is the same as the fraction of the circle. 6/12 is 6/12 of the circle, or 1/2. That looks an awful lot like this 1/2 section over here, doesn't it? And then if we go ahead and we shade 3/12 in, 1, 2, 3, that looks an awful lot like this 1/4 section right here. And we'll do the same with 2/12 and 1/12. Okay, so you get the point. The fractions of the whole that you're trying to express are going to be the same fractions of the circle when you're drawing it. All right, let's move on. Okay, let's do a couple problems. There are 200 chairs in a warehouse. 80 of them are plastic chairs, 30 are metal chairs, 40 are wicker chairs, and the rest are wooden chairs. The pie chart represents the number of chairs of each type. Okay, now just looking at this pie chart, even without having read the numbers, you could look at that and quickly see that they sold more plastic chairs than anything else. This yellow portion is plastic right here. I've got a little key down here for you too. Now your first question says, which type of chair is found in the greatest quantity? We talked about that. It's obviously plastic. And now we want to know how many wood chairs are there. Well, we know that there are 200 chairs total. So 200 is my whole. And to find out how many wood chairs we have, we're just going to subtract plastic, metal, and wicker chairs from 200. So 200 minus 80 minus 30 minus 4. And that's going to equal 50 wood chairs. Okay, now we want to know what fraction of chairs are plastic chairs. And we know that we have 80 plastic chairs and we have 200 total chairs. So plastic chairs are 80 out of 200. Let's write that as a fraction. Remember, my fraction bar means out of. And so we have 80 over 200, which when simplified equals 2/5. Then we want to know how many times as many plastic chairs as wicker chairs are there. Well, if I have 80 plastic chairs and 40 wicker chairs, there are 2 times as many plastic chairs. Okay, our next question says, is a pie chart that depicts the amount of money collected by various booths at a carnival. And you have some little squares on your notes that look like this. Those little squares mean that those angles are 90 degrees. So we're going to use this chart to learn that when you see this little 90-degree angle on there, that means that that section is 1/4 of the pie chart. And the reason it's 1/4 is because that there are 360 degrees in a circle. So if you were to divide 360 by 4, you would get 90. So 90 degrees equals 1/4. Okay? So when we have a question like what fraction of the total amount of money was collected by the games booth, we can look down here at our key. Games is blue. And since we've got a little square right there, we know that 1/4 of the total amount of money was collected by the games booth. Our next question asks, what was the total amount of money collected by the various vendors? Well, there's a problem here because I have amounts filled in for games, handicraft, and food booths, but I don't have anything for music, so I can't just add these. Well, what I can do, though, is use unitary method. I know that 1/4 of the total money was $3,000, so I can multiply both sides by the reciprocal of 1/4, which is 4/1, and that gives me 1 on the left side. And then when I multiply 3,000 by 4/1, I get $12,000. So we know that $12,000 was the total amount of money collected. Okay, now if we want to know how much was collected by the music booth, all we have to do is subtract. Whoops. Oh, I went a little bit too far back there. There we go. So I'm going to take $12,000 and subtract 6,000. I have two $3,000 booths there, minus 4,800, and I get $1,200 that was collected by the music booths. Okay, now we want to know the ratio of the money collected by the food booths to the money collected by the handcraft booths. Well, if we look at our key down here, food collected $4,800 and handcraft collected $3,000. So we'll set up a ratio that looks like this, 4,800 to 3,000. That's food to handcraft. And when we reduce that, we get 8 to 5. All right, now we have some boys and their breakfast. A group of 40 boys were asked to choose toast, cereal, pancake, or eggs for breakfast on a certain day, and the chart represents their choices. So if we just look at the chart, and we want to know which type of breakfast most students had on that day, obviously it's toast, right? You don't even have to read numbers for that. And then we want to know what fraction of the students had eggs for breakfast. So what we need to do to find the answer is we need to subtract all the fractions from 1. Remember that if we have a circle graph that's divided into fractions, we are going to have all those fractions add up to 1. So to do that, we need to switch to common denominators here. And since my lowest common denominator is going to be 20, we'll change all the fractions to 20ths. Okay, and you can see that when we subtract 3/5, 1/4, and 1/10, we get 1/20th, and that's the fraction that's left over for eggs. My next question asks how many students had toast for breakfast. Well, we know that 3/5 of the students had toast, and my total, remember, was 40 students. So we need to find 3/5 of 40 for that answer, which is 24. Okay, next, it says what percentage of students had cereal for breakfast. Now I need to convert that fraction to a percentage. So you already know that 1/4, or 90 degrees equals 1/4, which also equals 25%. And that is going to lead us into using circle graphs with percentages in our next few problems. But I'm going to stop the video here, and I'm going to do another one to demonstrate these last few problems because I'm about out of time. So that is pie charts with fractions for you.